the first law of motion. Now I am back to discuss with you the second and the third law of motion. First, we will discuss the second law of motion or law of dynamics. In the world of physics, the second law is one of the most important concepts. It is mostly used in every field. It tells us that the acceleration of an object which is produced by a net force is directly proportional to the magnitude of the net force in the same direction as of net force and inversely proportional to the mass of the object. That is, A equals F net over m, where A is acceleration, F net is net force and m is mass. The above equation can also be written as F net equals ma. We will discuss this law in detail, but let us first discuss what is net force. Consider you are pushing a block with a force of 50 Newton towards the right and your friend also pushing the same block with a force of 30 Newton towards the left. So what will be the force which will result in block's movement? That is force is the net force. Like in our block case, the net force is the difference between your force and your friend's force. That is 50 minus 30 equals 20 Newton. So the block will move with a force of 20 Newton towards the right as your force is greater than your friend's force. It must be kept in mind that force is a vector. So it can also be written like this. It means that the direction of acceleration and force are same. So if the force will points towards the left, the acceleration will also points towards the left. Now let's discuss the law in detail. Consider you are pushing a car towards the right which is 100 kg and its acceleration in the case is 1 meter per second square. So what is the force with which you are pushing the car? To calculate the force, we can use Newton's law. We have mass, we have acceleration. We can. Let's see. The equation is F equals ma. If you put the value of mass and acceleration, it comes out 100 into 1. That is 100 Newton. So the force with which we are pushing the car is 100 Newton towards the right. Let's take one more example. Imagine a boy pushing a wooden block towards the left with a force of 50 Newton and acceleration 2 meter per second square. So what is the mass of the block he is pushing? To calculate the mass, we have to somewhat modify the equation. We know that F equals ma, and to calculate mass it comes out m equals F over a. Perfect. So if we put the value of force and acceleration, it comes out m equals 50 over 2. That is 25 kg. So the mass of the block he is pushing is 25 kg. You have to be very careful regarding units. You should know that 1 Newton equals 1 kgm per second square. So if you calculate mass, it will mean kilograms. If acceleration, it will be meter per second square. And if force, it will be newtons. All these cases were of motion in x-axis. But if the motion will be in y-axis, then the acceleration will always be taken as 9.8 meter per second square. That is acceleration due to gravity. But there can be one more case. If the force will act at an angle like this, then how shall we calculate the magnitude of the force? For this, we have to use trigonometric functions. Like in this case, we know that cos theta equals net force exerted in x-axis over total force exerted. So if we evaluate this, we get net force exerted in x-axis equals total force exerted times cos theta, and this is the net force exerted in the x-axis. For y-axis, we have to use another function. Like we know that sin theta equals net force exerted in y-axis over total force exerted, and if we evaluate this, we get net force exerted in y-axis equals total force exerted times sin theta, and this is the net force exerted in y-axis. Let's take an example for better understanding. Consider a pot of 10 kg which is acted upon by 4 forces. Now let's calculate its acceleration in both axes. First in x-axis. We know that acceleration in x-axis equals net force exerted in x-axis over mass, and which turns out F2 minus F4 times cos 45 over 10. And if we put the values of F2, F4 and cos 45, we get 15 over 10, that is 1.5 meter per second square. And this is acceleration in x-axis. Now let's move on to acceleration in y-axis. We know that acceleration in y-axis equals net force exerted in y-axis over mass, and which turns out F1 minus F3 over 10. And if we put the values of F1 and F3, we get 2 over 10, that is 0.2 meter per second square. And this is acceleration in y-axis. So now we have come to know that acceleration in x-axis will be 1.5 meter per second square and in y-axis will be 0.2 meter per second square. Now we have understood how to calculate mass, acceleration and force by using Newton's second law of motion. So now we can move on to Newton's third law of motion or law of action-reaction. Hey, you're here. Let's talk about Newton's third law of motion. Have you ever think of when you punch a ball, you felt the back force acting on your hand. Harder you punch the ball, harder is the back force. Why this happen? Does the ball exert a back force on your hand? The answer to this is yes, the ball exerts a back force on your hand, which is explained by Newton's third law of motion, which says that every action has an equal and opposite reaction, given by equation that force exerted by A on B is equal to the negative force exerted by B on A. Here the negative sign means in the opposite direction. Let's take an example for better understanding. Imagine you are on a skateboard and has a cricket ball in your hand. If you throw the ball in the forward direction, you will see that you will move in the back direction. This is due to Newton's third law of motion. One thing to note is that the force with which you throw the ball is equal to the force with which ball pushes you back. This law represents a symmetry in the nature that forces always occur in pair. One body cannot exert a force on another without experiencing a reaction force on itself. So we have also covered up Newton's third law of motion and can understand any phenomena related to it. Thanks to listen my video. Please like my video if you feel it helpful and subscribe to my channel Knowledge Row for more knowledgeable videos.